All right, so we left off yesterday. I said we were going to talk about types of propeller configurations. Types of configurations. All right, so we have all different kinds. A picture's worth a... We'll look at pictures. We talked about that yesterday with the clearance. Oh, speaking of, I'll make a step back here. I did mention yesterday where we got all of these dimensions was from FAR Part 23. But here's the problem with FAR Part 23, which is Certification Standards Normal Utility and Aerobatic Category Aircraft, is that the FAA has recently made a major change to Part 23. So for a very long time, the FAA would say, this is exactly how you have to build an airplane. And then they went away about 2 years ago, and they call it performance standards. So in other words, it's instead of saying, you must have 9 inches clearance between the prop and the ground, a better example now is, you're the one making the airplane, you make it the way you think it ought to be, and then we'll check it out. Kind of a way. So these hard, fast rules have really gone away, and it's more up to the manufacturer to produce an aircraft and then prove to the FAA that what they've designed actually works. So in other words, if maybe if a manufacturer at one point had 8 1/4 inch clearance, the FAA would have said, nope, that's a no-go. And so you'd have to redesign the landing gear, do something else. But now, if you could prove that whatever you have right there is adequate, excuse me, then it's fine. So that's why I'm quoting these things out of FAR 23, but it's the old 23. Now, why would I do that? Because guess what's still on the oral practical tests and the written tests, these numbers. So until those numbers go away, and I can see they go away, I'm going to keep up with this. So at some point, I guess it'll get easier, and they won't have these numbers. And the question will be, what is the clearance required for a tricycle landing gear? And you will say, oh, whatever the manufacturer deems appropriate and the FAA buys off on. All right, so different types of propeller configurations. Well, this is called a tractor configuration, and I picked an air tractor to prove that. So this is an air tractor. That's actually the name of the aircraft, and that's a typical, you could call it a tractor configuration where the prop is out front, works like normal. What kind of engine do we have up there? Radial engine, okay. So mounted on the prop front, and the prop is pulling. Then we've got a pusher. What does this look like to you? It is, but I mean, what kind of car? What's that?
Looks like an Airstream to me.
Okay, well, I was hoping to hear from you, actually. It looks like a VW bus to me, too. I've always thought it's a flying VW bus. That's called a CB. It's called a CB. So, all right, so prop is mounted on the rear. More susceptible to damage from rocks being kicked up by the main landing gear or spray being pushed back there. So you have it's a little more susceptible. That's why you're going to find them usually mounted higher up. Even if you think about our Skymaster outside, the front prop is much lower than the rear. The rear they put up quite a bit higher. So you got longer takeoff runs, right? Wow.
Because you have the rotation of the moving it forward.
I don't know. If you say so. All right, then we can combine it, and we got a pusher puller. What kind of plane is this? Well, the civilian version would have been a Skymaster 337. They also made a 336 version with fixed gear, but this is a military version, making it a Prince. The one thing he doesn't know. An O2, I believe. So it's got one prop up here and one prop in the back. Can you think of any other configurations? Side by side. But that's two pusher.
Counter rotating.
Oh, yeah. That's still a tractor configuration, isn't it?
Well, kind of, but it's 2.
It's 2, but it's tractor.
What makes a tractor?
Prop up front. Prop up front pulling.
Oh, yeah.
That's it. So we had, I'll write these down. So we had the tractor. That is prop mounted up front. with prop pulling. So I said, oh yeah, that's I got a tractor configuration, which most people don't say. It's just your typical. You have a pusher. That's where engine is mounted on rear. Thinking back to building your Lycoming, can you think of a problem with a pusher type prop?
Has to be built reverse.
Right? There's cooling problems. They don't cool as well. That was a big problem with the Skymaster. The rear engine doesn't cool well at all. In fact, I think I'll speak out of line, but I've heard, I don't know this for a fact, but most pilots who've owned them have told me they usually shut down the rear engine right away. As soon as they land, they just shut it down. They don't want to taxi with it. It doesn't get good cooling.
The thrust bearings are different?
There you go. Thrust is, it almost looks like the engine wasn't designed that way. It's actually riding on the slinger rings up front. And that's all you get for the thrust. Speaking of the Skymaster, and I think it's an airworthiness directive, that if you're flying a twin, you're going to grab both handles. You need to go forward on a twin, both engines at the same time. It's a twin, but you don't do that in a Skymaster. You have to take the rear engine and lead with the rear engine and get your airspeed with the rear engine, and then bring up the front engine. Anybody care to guess why? What's that? Nope. Because there are several instances where pilots are grabbing both handles and going forward. You cannot hear if the rear engine or see what the rear engine's doing. You can look at your manifold pressure, but what's your manifold pressure at takeoff?
Near sea level.
Near sea level. What's your manifold pressure when the engine's shut down? Near sea level. So your manifold pressure is the same at max power or off. So you can look down. Well, of course, your RPM should be working, but it's not something you're usually looking at during a takeoff roll. You're watching the center line, watching airspeed, center line airspeed. You don't look over at TAC. You're just kind of feeling things. And there have been many instances where Skymasters have taken off on single engine, and the single engine performance is pretty dismal in that aircraft, really. So you lead with the rear to make sure the rear is actually working, and build up a little speed before you bring the front. That way you know you had some thrust in the back.
It's like a 172 with 4,000 pounds.
Yeah, it's a good point. It's about the same. It's a little bit bigger engine than a 172, but not by much. It's a much bigger plane. All right, so pusher, engine mounted on the rear, more susceptible to rock damage. The prop is anyway more. To rock. I should say more, hang on. Damage, more susceptible to damage from rocks.
Couldn't you just say bod?
Nope, couldn't say that. Or spray from water landing. What's that?
On the 337, the rear propeller, is it less efficient because it's getting this air kind of messed up from the front propeller?
You know, it's funny. I would think that it would be, but the looks of it, the propeller is actually smaller.
What are you talking about?
Propeller, the rear propeller on the Skymaster.
So the interference between the two?
Not necessarily the interference between the two, but more the interference of the airflow going over the airframe. So you can get, and we'll talk about this much later, resonance between the two, just like with any other twin. And so the newer models had synchronizers and synchro phasers on them. So you can actually time the propellers to be at a certain spot.
Doesn't that mostly create noise though? It's just noise. That's a result.
Okay.
It-
Noise and vibration.
Yeah.
But you're asking me if it's more noise than vibration?
No.
Okay. Where am I here? Usually mounted higher. And we have both push-pull.
Is that also called tandem?
If you want it to be.
Okay.
Push-pull. They call them push-pull. They call, yeah, tandem. Where are we? And that was like the Skymaster. All right, types of props. All right, what do we got here? Your standard fixed pitch propeller. Does the blade change? It does not. It's fixed to a point. Can you change the blade angle? Yeah, you can if you try hard enough. I've actually watched it done. It's quite interesting to watch how it's done. It's the guy I watched do it brought in a prop for repitching, and he just kind of go in the back of the machine shop. He's got a cigarette in one hand. He kind of takes this thing and he shoves it in this hydraulic monster of a machine, and he reaches in a garbage bin, and grabs a bunch of wood blocks and shoves it in there and pulls a handle. These giant claws come down and just smash all the wood and grip a part of the propeller, and then does it to the other side and does that, and he's just got a handle, and a cigarette in one hand, and all he's got is a pressure gauge. Just kind of pulls this handle and the whole thing twists. He just kind of watches it and he's like, yeah, that looks about right, and he takes it off, and it was amazing. The guy takes it off, he puts it on a prop table, gets everything set up. I'm off by about maybe 1/8 of a degree. He shoves it back in there, just one little pull on it, brings it back. Yeah, that's perfect. There you go. So it was an art. I mean, it's like, wow, okay. So fixed pitch. So yes, you can actually change the pitch on them if you have a cigarette in the machine. All right, ground adjustable props. So this is something that you'll have an opportunity to actually adjust. You can adjust each blade on the ground. You don't try it in the air. If you do, give me a call. I want to watch. So you just undo these clamps right here, down there, and the blades will rotate quite easily. And so you'll do that. What else do we have? This is, I think, my representation of a 2-speed propeller. So a 2-speed propeller, which have a 2-pitch, high and low speed. So it's like 2 gears. We'll talk about that. I think that's a Beachy Electric propeller. And this is not a constant speed, but a controllable propeller. So, and I'll write notes. We'll talk about all this in much more detail. This particular one was electric and had a little switch. So you can put a little more pitch and a little less pitch, a little more pitch, a little less pitch. And it would move this little, this electric motor, would move the little pinion, which moved the gear, and it would move the blades.
So the governor was manual?
Yep, manual governor. So you would just dial in whatever pitch you want. You want a little more pitch, a little less pitch. And before this, actually, the precursor, this is the fancy one with the electric motor. Before this was a little crank. I would say like the old, you guys even know what this means, right? Yeah, but they don't know. That's, why is that? It's more like this nowadays. Is that up or down? All right. This is an automatic propeller. And we used to have one, but somebody walked away with it. It's Comper's aromatic propeller. We'll talk about this later on, but it actually automatically, not with a governor, is completely uncontrollable by any, you had no input at all, but based upon speed and RPM, it would find the best pitch. And they're pretty cool. In fact, if you look at it, this is just an old, I think it's an Aronca Chief maybe, or something like that. Cessna 140. Then we get into the constant speed propellers, which are set by a governor. So pilot will set the governor to an exact RPM, and the propeller blades will move to match that RPM selected by the pilot. So we have all of those different types. I think that's, guess we can go one more. Feathering props. So constant speed, and then one step up is feathering. So if you notice, this engine's running. You can see the outline right there. And this end is not running. And you can see that the blades are going right into the wind so that it's not windmilling. So constant speed feathering. Let me see what the next picture is. Just test club. A video. No.
Is that how they make them? Or?
Yeah, we'll watch that. All right, test club, constant speed feathering, constant speed, automatic, adjustable, 2-speed. And by the way, that could be at constant speed. They look the same. Ground adjustable, fixed pitch. Got it?
Mm-hmm.
All right. Does that mean you're ready for the test? All right, fixed pitch. We'll say that's a rigid prop. Blades do not adjust unless, like I said, you've got the machine to do it. But you can have them repitched. Ground adjustable. We'll say blades can be adjusted on the ground with proper tools. Now you could adjust it without proper tools. It just doesn't work as well. Why would I want to adjust the blades anyway on the ground? What's that?
For different altitudes.
Different altitudes. So let's say I have a customer that says, hey, normally I just fly up and down the valley, but I've got to, I don't want to say different altitudes. How about somebody flies up and down the valley, but this time saying, you know what, I got to make a couple stops. This time I'm going to be spending a week out on a runway that's very short. So I need a significant climb prop. I need to get up and off this runway rapidly. So would I want to give them a higher pitch or a lower pitch?
Lower pitch.
Yeah, lower pitch. What's it going to do to airspeed overall?
Low it.
Drop it, but better climb prop. So, or maybe same scenario. The guy says, hey, okay, I'm back, and now I'm going to take my airplane. I'm going to go all the way across country.
Or distance, cruise prop.
A high pitch, yeah. So,
What about if, like, say, for instance, they're in the equatorial area and they want to go, fly
In the
the-
what area?
Like equatorial area,
okay.
and they want to fly the plane in, like, the Arctic or something like that. Would you change the pitch because the air is more dense when it's colder?
Well, if you're talking about the equator,
Yeah.
well, actually, when you cross the equator, the engine has to turn the other way anyway. So then you got to reverse the blades all the way around.
Is that gonna mess up your paint even more, Kevin?
It pushes back the other way towards the hub.
But if they're like in a hot region, then if they go to like a colder region, wouldn't the density of the air be different? So you want a different prop pitch, or?
I'm going to say no.
Okay.
It's because basically, hope I'm right on that. The reason why is because when the air is less dense, then the engine performs less, and so it still matches. So you're either going to go with basically a cruise type prop, a climb type prop, or an in the middle type prop. So if you look at most aircraft on the type certificate data sheet, and they pretty much give you just that range. You can have, there's different manufacturers, but if you really kind of digest it, you're either getting a cruise, a climb, or in the middle. And guess what almost all airplane came with? In the middle. And the difference between the two is not a lot, especially on like a little 150. Ground adjustable. All right, then we had the 2 position. Allows the prop to be in either low angle for takeoff or climb, high angle for cruise. And the picture that I showed was a Hamilton standard. $12D40. Not to be confused with the more famous WD-40. That's not real, by the way, so don't. I mean, it's really a 12D40, but the WD-40 was just a bad joke. So,
You
all
said
right.
you can't use WD-40 for a prop?
You can. You just spray it all over the outside and then wipe it off. All right, controllable. And this one had either the motor or the little crank on it. So pilot can adjust the pitch of the blades. And the one I showed you is a Beach Roby prop.
How popular is controllable pitch?
I've never seen one. Even the Beach that originally came out with it. So maybe I have. Maybe I think I had one customer had one. But really, you're either nowadays you're going to have the fixed two position is still reasonably common on older planes with radial, or constant speed.
Is it two-position adjustable on flight?
Yes, it is adjustable in flight. There's a handle, high speed, low speed. And off, not flight, but ground adjustable, you can adjust it on the ground.
So Kevin,
Yes.
if you're coming into landing with a controlled pitch, you're gonna want to switch back to low pitch when you're coming into landing.
Yes.
So what if you lose power when you're up in the air?
What if you lose power when you're up in the air?
Because it's electrically driven, isn't it?
Oh, I'm sorry, controllable.
On the controllable.
Well, then you're stuck with what you got. That's a simple answer. If you have no electricity and you can't adjust the prop, then you've got nothing you can do. Unless you have the old crank style, and you can crank it. So then you're just coming in on a high pitch. What's that
You
one?
want to come with low pitch.
Yes, what he said. You want low
Oh,
pitch.
okay.
He said, but with the controllable, this electric controllable, what if you lost your electric system? And you're,
Stuck on whatever.
well, tell you what, if you think you're going to lose your electrical system, go into low pitch before it happens. Automatic pitch. And this is the pitch of the blades are automatic or fully automatic based on aerodynamic loads. Based on aerodynamic loads.
How many of those have you seen?
Not many at all. There's a guy who took over, who bought the company, who's doing it, and he's still in business and he's still doing them. But the problem is, I don't think they're type certificated. Or at least last time I looked, they weren't. And I don't think home built's are real crazy for them, so it's a very small market. But they were type certificated to go on a lot of planes. So I've seen it on a lot of type certificates that you could put it. And he said we had one, and I don't know, walked away about 2 years ago.
I think Rotax
Rotax is doing a fully automatic.
is where their experimental stuff.
Yeah, it's a Compers Aromatic is the I think I wrote that here. Yeah, this is a.
So you guys should have someone left with like a whole problem.
They're not real big and they're really light. They're really lightweight wood. So this is a. I think I spelled that right. Compers. All right, then we've got the constant speed, which nowadays you pretty much have either the fixed or the constant speed in any modern aircraft. So it uses a hydraulic governor to automatically control blade angle and the way that's done is the pilot sets the RPM and blade angle changes to hold the RPM. So if I've got it set for a certain RPM, say 2,500 RPM, and I'm flying along and I pull back on the stick, if I have a fixed pitch propeller, what's my RPM going to do? It's going to drop. But if I got a constant speed, what's my RPM going to do? Stay exactly the same. And it does that by flattening out the pitch. And if I go into a dive, it'll try and do the same thing. Now it's limited. It can, can't go straight up. It's like, well, thing is broke. It's got a range. It's like anything, but that's its job, is to try and keep the same RPM. Let's see. Oh, options. So what do I have here? I've got feathering. So not all are feathering. If it's typically only going to feather if it's on a twin engine aircraft. And if it is a twin engine aircraft, you bet it's going to feather. It's just there are a few planes out there. I think they're all ag planes that are single engine feathering, but that's pretty rare.
So one data point, we always teach that a windmilling propeller produces as much drag as the rest of the plane.
Really?
And the comparison was like
That's a lot.
helicopter coming on auto rotation.
Yeah.
How much drag that produces to produce a soft landing on a helicopter.
Oh yeah, that's a good point. So drag is equal to right there.
So in the small twin engines, if you don't feather the propeller, you're not going to go up.
And then your single engine protocol to
I was, Kevin,
Yeah.
I was reading about Berger's hand, one of his experiments, and he said they found that a windmilling propeller produces 4% more drag than just a solid disc of the same size. Supposedly what they were able to come up with.
I could see that because you have to drive the engine too, so you have the drag of the engine. That's insane. That's a lot. So that's why you want to feather it.
And in some airplanes, if the auto feathering system is not working, it's a no-go. Like on the...
Oh, it's not in the MEL.
No, it's for example, the King Air with 4 blades.
Uh-huh.
With 3 blades, it's okay, but the one with 4 blades, if the auto feather is enough, it cannot go.
Okay.
Because it will be impossible to control.
But if it's a 3-blade prop, it's in the MEL that you can fly it. MEL's minimum equipment list. So if something's broken, you reference this list and they'll tell you if you can fly with or without it.
Yeah.
So 3-blade you can go without the auto feather.
Yes.
You're talking auto feather, right?
Yes.
Okay. So we'll talk about auto feather later, but well, right now, auto feather is actually a function where because it takes a long time for a pilot to register which engine has gone. There's an engine problem. It has gone out. React to the feather. And if you're just taking off, that's when bad things happen. So some aircraft have an auto feather where it senses the loss of thrust and automatically feathers just that fast. And I'll tell you, when I went to Simuflight and did training in the Citation, that's the twin engine airplane, we were doing fire simulations, right? And so I was like the third guy to go. And it wasn't like it's a big secret. I'm sitting in the back of the simulator watching the people in front of me. And the instructor says, okay, we're going to do a fire. I'm going to simulate a fire in an engine. And so, and the whole thing was, so he would do a fire, and then this was for mechanics. And so we were supposed to, know what to do, shut down properly, First guy couldn't do the procedure right. Really kind of botched it. Second guy, it was a little bit. I was determined I was not going to botch this. And I knew the procedures inside and out. I was ready for this. I knew what was going to happen. The guy hit the firelight. I did the procedures by the book perfectly from memory. And he looked at me and said, that was fantastic. You did perfect, except for one small detail. You shut down the good engine. It's just, and from that I realized just how easy it is to do that. And so, I never point fingers at pilots like, that pilot shut down the wrong engine. Well, I can see how easy it was for me to do it, knowing what was about to happen. Now imagine you're taking off and things go to, heck in a handcart. I can see just how simple it would be to pull the wrong engine. I'll even
So that all the time in the simulators.
the wrong one.
Yeah.
Oh yeah, it's just too easy to do. All right, and I'll even when you guys, thanks to Juan and Josh for getting the SkyMaster up and running, we'll be using that later in this class to go out, and I'm going to show you how to run a constant speed propeller, what the manifold pressure does. Normally we use the V-tail, but we'll use the SkyMaster now that I have twin, and I'll show you. You'll grab the wrong things constantly. Slap in your hand. Don't touch that. Okay, so feathering. Let me see. We have same as constant speed. Same as constant speed. Well, it is a constant speed, really. But prop can be feathered. Everybody knows what feathered is, right? That's high angle directly into the wind. And that's used on twins. To reduce drag. And windmilling. Of a failed engine. Because not only does it create drag, which if you're a pilot you really care about, but if you're an engine guy, well, the engine failed, you don't want to keep slinging stuff around in there. Feathering, let me see. Please don't make any sense. Reversing. So not only can you go feather, which is all the way this way, but you can go flat pitch and a little bit backwards. So you can actually reverse the thrust out the front. Sometimes called beta range. We'll talk more about that later. Blades. We'll say blade angle. Can be moved. Pass low pitch to a negative thrust. Beta range. And then we had, where are we? G. Test club. A short prop that directs cooling air along the engine. Designed to absorb max engine horsepower. So if the club is designed properly, it's set out the horsepower. In fact, if you look at some of the test clubs we have hanging up on the wall around the shop, like the one over the ATC lab, it actually has stamped right on the horsepower of the club. And while you're catching up with the notes, I'll tell you a stupid story. I built an engine one time. I built one engine. And we didn't have a test club for it. And so I ordered a new test club. And it came as a 2-bladed wood prop. And so I built the engine in one shop. We sent it to our other shop. They installed it on the airframe, installed calibrated gauges, got it all set up. Test club came in. I sent one of my mechanics up. I said, go ahead and put the test club on, run the engine. He calls me back, says, Kevin, your engine, it's really rough. It's a really rough running engine. Oh, that's really weird. What do you suppose it is? Well, double check the mags. Oh, mags are great. I mean, you troubleshot this thing for like ever. And I said, well, I'll come down and take a look at it. Go ahead and start it up. And the thing just shook like crazy. I'm like, shut it down, man. Like, could you try measuring the prop? They built it offset by like, I think it was some crazy number. It wasn't like a 1/4 inch. It was like 1.5 inches or something. The hub was offset. And you could even see it when you walked up to it, like, it's not even centered. So I sent it back and I was into that. All right. So given all that, now we've got a good overview of props, nomenclature, different types of props. Let's talk about fixed pitch specific. So, fixed pitch props. And over the next few weeks, we'll talk about, with the exception of the test club, because it's just a fixed pitch prop, we'll talk about all these other props you just talked about in much greater detail. All right, so according to my notes, we can watch this guy because it's kind of cool. Let's see if it works. Back up. There we go.